Hello everyone, and welcome to an example on calculating the log mean temperature difference. So here we have a counter flow double pipe heat exchanger. It means that we are looking at only one shell and one tube, and the fluids are moving in the opposite direction. And so our cold fluid enters the heat exchanger at 20 degrees centigrade and leaves at 80 degrees centigrade at a flow rate of 1.2 kilograms per second. While for the case of our hot fluid, it is entering the system at 160 degrees centigrade at a flow rate of 2 kilograms per second. We know the inner diameter of the tube, we know the overall heat transfer coefficient, and we need to calculate what is the logarithmic mean temperature difference. And as you can see the hints here, so first it means you need to calculate what is the missing outlet temperature of the hot fluid, and then we can calculate the log mean temperature. So maybe if you pause the video for a bit, try to solve this question and then have a look at the solution. Okay, so let's look at the solution now. So first thing, always try to draw a simple schematic diagram just to so that you have all the information visible to you on this diagram. So here again we know the temperatures, inlet and outlet temperature of the cold fluid, their flow rate. We know the inlet temperature of the hot fluid, its flow rate, but we don't know at what temperature it is coming out. And also we need to know what is the CP of the system, okay, because we need it for the calculation. So the first thing that you need to do is to calculate this temperature here. And how we can calculate this temperature is by doing energy balance. So we look at how much heat is taken up by cold fluid from the hot fluid. So we know that the equation of heat content of a fluid is Q is equal to mCp delta T. Okay, M is given to us. Cp we can find out from our steam table, and we know the inlet and outer temperature of the water. So the overall heat that the cold fluid is carrying in this heat exchanger is 301 kilowatt. And now from energy conservation, and we assume there is no heat loss in the system, all this heat should be coming from the hot fluid. Okay, and that is exactly what it is. So we know the same equation for hot fluid, mCp T in minus T out, and we don't know the value of T out, so we rearrange this equation in the form of T out. Sorry, and then we have the equation in the form of T out equal to T in minus Q over mCp. We know all these values, so if you plug the values in the equation, we know what is the outlet temperature of this hot fluid. Okay, so we know what this temperature is here. And now we know four temperatures. It means the inlet and outlet of hot fluid, inlet and outlet of the cold fluid, and it means that we can calculate log mean temperature difference. So we need to first calculate delta T1 and delta T2. It means the temperature difference on one end of the exchanger and the temperature difference on the second end of the exchanger. And that is exactly what it is. So we have delta T1 as 80 Kelvin, and we have delta T2 as 104 Kelvin. Okay, and just to clarify this, why we have centigrade here and then we convert it into Kelvin, because the temperature difference in Kelvin and centigrade should remain the same. Okay, because if you add plus 273 here and plus 273 here, the delta T would be the same as 80 degrees centigrade or 80 Kelvin. Okay, so if you now put the values in this equation here, so we can write delta T as 80 minus 104. And please be careful if you are using this equation, delta T1 minus delta T2, then delta T1 should be in the numerator, not in the denominator. Okay, so please be careful which equation you are using. And if you take the values, you have the final log mean temperature difference as 91.5 Kelvin. Okay, so this is how we can calculate the log mean temperature difference from a heat exchanger. Thank you for your time.